So one primary use was to make predictions for outputs y or y values using this y hat, the output of a regression line. Our second is to actually quantify this linear relationship between x and y. It's to help us say something more nuanced than just, yes, there's a linear relationship between x and y. But what is that relationship? What can we say about it? It's essentially intended to go a little bit deeper. And to do this, what we do is we use the coefficients of the linear regression line that have been provided to us. So let's talk about how to quantify this relationship between x and y. So basically, after fitting a linear regression line, you'll get something of this form. You'll have a y hat, right? This is the output. This is your best prediction for the y value based on a particular input value x. And coming with it, you'll have numbers where the slope is sitting, which we'll call m, and where the intercept is sitting, which we'll call b. And this is hopefully a familiar form from algebra or precalculus whenever you last saw linear equations, right? This is what we call slope-intercept form. It's the slope times x plus the y-intercept. The slope is a very interesting and important piece of information. The slope of our regression line essentially tells us what the expected change in our output variable in the y values will be based on a 1-unit change for x. In economics and in business, we often call this the marginal change. Let's explore this a little bit deeper. So what is the slope for a line? How does the slope of a line work? Well, you may remember from some of your math classes in high school that slope is computed for a line essentially just by looking at any 2 points on the line. What's the change in the y values divided by the change in the x values? So let's go back to our flour and our cake examples. So let's assume that the best predicted value for the price of cake can be given by 4.202 times the price of flour plus this extra little intercept bump of 1.765. So the question becomes, if the price of flour, suppose we get an inside tip that the price of flour is going to increase by 10 cents, what's the effect on the price of cake? Well, keep in mind here, the slope of our the slope of our linear regression line here is the 4.202. So in our equation, we're just going to replace slope with 4.202. Now, the price of flour and how it increases, right? This 10 cents, this positive 10 cents, is really the change in x in that formula. So we get to make that replacement. Now, what is the effect of the price of cake? Well, we can describe the effect in terms of this change in y. Keep in mind, change in y, if we solve, right, multiply both sides by 0.10, change in y is really telling you what's the change that we would predict in the price of cake. And so taking 0.10 times 4.202, we get a change in y of about 42 cents. So our conclusion here is if flour increases by 10 cents, we would expect the price of cake to increase by 42 cents. And these are always expressed in terms of changes, right? If you change x by this amount, how much is y going to change by? And this is the nice quantification of the relationship between x and y that we get by looking at that slope term. It tells us if we know what to expect for changes in x, it gives us a sense for how the y values are going to change as well. So with that example, I think we're ready to answer this next question. So we're wondering, if we increase the age of a customer by 5 years, what kind of change should we expect to see in their purchase total? Right? And again, we're trying to estimate this using our linear regression line. So based on what we looked at before, the slope of our regression line should represent a ratio between the change that we would expect to see in our response, in this case purchase total, divided by the change that we actually see in our input, which in this case is our age, our predictor variable. So what do we know here? Well, our change in x, this is going to be equal to 5 years. What's the slope that we're going to use for our regression line? Well, we could either read it from our plot if we decided to show our equation on the plot, or remember you can do slope, the slope command in Excel to get this as well. So this would be B2 out to B33, A2 out to A33. And again, remember, it's critical that the response variable comes first, and then the predictor variable comes second. So y's have to come first, x's have to come second. Okay, and we'll notice these are already matching up. So change in y, well, what is this going to be? From what we saw over here, when we end up talking about the change in y, we ended up kind of solving this slope equation for change in y, multiplying both sides by change in x. So here's the one that's used in practice. Change in y is really just the slope term times the change in x. So we can compute this. Slope term times change in x, or negative 1.15 times 5. And this gives us an estimate for what kind of change we would expect to see in y. Now let's actually interpret this, because it's very important to know what that number actually means. If our x value, if the age of our customer increases by 5 years, the change in y is negative. When we're dealing with changes, negative changes means a decrease. So our purchase totals are actually going to decrease by the magnitude of what's left over. So the way we would interpret this is we would expect a decrease, again, because of the negative sign in that answer, of $5.75 in the purchase total, based on our regression line and based on this idea that we're expecting a change of 5 years, an increase of 5 years between the two customers. The natural next question to ask is, all right, if I understand how the slope works, what kind of information does the intercept term give you? Well, the intercept, the y-intercept specifically for the regression line, is the predicted y value if your input is 0. Now, this may or may not be important information. And what I want to do is just for as an example, consider our case over here of age versus purchase total. Our intercept term is 221.81. Now that's a predicted purchase total if the age of our customer is 0. Well, that doesn't really make sense. We don't have newborn babies inside of our store purchasing things. So the intercept, depending on the context, may or may not be giving you any actionable information about the relationship. Now, in other cases, this is interpretable. If having an x value of 0 is within the realm of possibility for you, the prediction there could be important for you. But that's essentially what the regression line intercept term tells you. It's the predicted y value, assuming that your input is equal to 0. So you do have to be careful with that. The slope just about always gives you meaningful information. And just for your own reference, inside of the slides, these are the commands that allow you to get those slope and intercept forms without actually fitting the trend line or doing a full regression analysis with a tool pack, which we'll do later this week.